Hello everyone, this is the third episode on alcohol, phenols and ether, and this is a special episode. Do you know why? Because we are going to go for interconversion of alcohols and also have different taste on alcohols. By this test we can understand the primary, secondary and tertiary alcohol. So here we go. Please see the board. Here I have for you the interconversion. Say this is methanol. Methanol is 1 degree alcohol and they have only one carbon. We have to increase the number of carbon. In this case, what we are to do is, first you treat the alcohol with HI, hydrogen iodide. You know that hydroiodic acid is a very strong acid. It can displace hydrogen very easily. And in that case, this hydrogen reacts with the hydroxyl part to remove it in the form of water. And you get here CH3I. This CH3I is replaced by the CN present in KCN. So when you treat KCN, the cyanide part will be replacing the iodine to form CH3CN, and here potassium iodide also will be released. This methyl cyanide reacts with the hydrogen. Usually we take lithium aluminum hydride, LiAlH4. They are the supplier of hydrogen, so you can understand it is a reduction process where two hydrogen comes and unite with carbon and two hydrogen comes and unite with nitrogen to form amine. When amine is treated with HNO2, that is nitrous acid, we get here ethyl alcohol. This is also 1 degree alcohol. What is the difference between the two is, I have started with 1 carbon, it has gone with 2 carbon. So this is the way by which you can increase the number of carbon atoms and you can get the alcohol in the same time. Now let us take a reverse. So while we go for a reverse, here you can see the number of carbon atom is 2. Here I am going to make into 1. So ethyl alcohol to form into methanol. Let us see here when we are oxidizing it. When we are oxidizing with K2Cr2O7 in the presence of acid, here the acid is concentrated sulfuric acid. So what it happens is it loses out the water. It loses out the water to form here acetaldehyde, aldehyde. Aldehyde on further oxidation with the same compound like K2Cr2O7 in the presence of acid medium or KMnO4 or copper oxide at 300 degrees centigrade or P2O5 at 350 degrees centigrade. So you get here acetic acid. Acetic acid with treating with soda lime. On treating with soda lime, we get here CH4. CH4 on substituting reaction with chlorine in the presence of sunlight, we are going to get CH3Cl. This chlorine will be replaced by the OH present with NaOH or KOH. So student, you can use here both KOH or NaOH. But be careful, there should be written aqueous. If aqueous is not written, we are going to cut away the marks from here. So again, I will be telling you, you can go either with aqueous NaOH or aqueous KOH, where chlorine will be replaced with OH and potassium chloride will be forming as a byproduct. In this way, you can turn 2 carbon atoms to 1 carbon atom in the manufacturing of alcohols. So the next thing is to turn 1 degree alcohol to 2 degree alcohol. So or primary alcohol to secondary alcohol. So let us see. Here in this way, we can form that CH3, CH2, CH2OH. So student, you know this is 1 propanol or propan 1 ol. When we are treating with thionyl chloride, SOCl2 is thionyl chloride, what happens is you can treat with hydroiodic acid also. So here you can take PCl5, you can take PCl3, you can take SOCl2, it's up to your use. So it will replace this OH with a Cl. Now with alcoholic KOH, it is going to form unsaturated hydrocarbon. What it happens is This alcoholic KOH takes one hydrogen from here, one chlorine from here, and this hydrogen reacts with the OH to form water, and K will take this Cl to form KCl. So these two will form as a byproduct. So nevertheless, you should say like this, that hydrogen and chlorine form as HCl. No, it cannot happen. So what it happens, the hydrogen reacts with OH to form water, and the chlorine reacts with K to form KCl. So these two as a byproduct can be subtracted out. So you get here alkene, or here 1-propene. So when you are treating with HBr, remember this is Markovnikov's rule, this is H plus and Br minus. I will just revise it, the Markovnikov's rule once more. Please listen very carefully as I say. Markovnikov's rule states that, Markovnikov's rule states that when an unsymmetrical alkene reacts with an unsymmetrical polar reagent, the negative part of the addendum goes to that part of the carbon atom that contains the lesser number of hydrogen. I repeat, I may be too quick, be careful while I say. When an unsymmetrical alkene, so this is an unsymmetrical alkene, reacts with an unsymmetrical polar reagent, the negative part of the addendum will go to that part of the carbon atom, will be going to that part of the carbon atom that contains a lesser number of hydrogen. So here the lesser number of hydrogen is with this carbon, so bromine or the negative part goes to that very carbon that contains a lesser number of hydrogen. And so this H will go to the higher number here between the double bond. This is the lesser number of hydrogen, so negative goes. This is the higher number of hydrogen within the double bond, so the positive part goes. So you can get here 2-bromopropane. So when this 2-bromopropane is treated with aqueous KOH, this Br will be replaced by OH. So 1 degree alcohol turns into 2 degree alcohol. So 2 degree alcohol, yes. So student, you can understand this is isopropyl alcohol. Nowadays, you know this is the isopropyl alcohol which is used in hand wash. So as sanitizers, as a hand wash, we are using this 2 degree alcohol or 2-propanol, and it is used with many kind of ingredients. But the main base, 90% of this isopropyl alcohol is used as a sanitizer because it helps to kill the virus, it helps to kill the other microorganisms. So from this propanol to 2-propyl alcohol, so we can make the transformation. Similarly, if you want to go with 1 degree alcohol to 3 degree alcohol, let us see the difference, how we are going to interconvert the compound from 1 degree to 3 degree. So this is 1 degree alcohol. How can you understand this is 1 degree? Because the alpha carbon is sp3 hybridized, and also it contains the hydrogen. It doesn't contain any alkyl group. So when the OH when this functional group OH is attached to that very carbon containing hydrogen, so it is 1 degree. But let us see how we are transforming it when we are taking concentrated H2SO4. When we are taking concentrated H2SO4, what happens? This hydrogen and this hydroxide part, it is removed in the form of water. It will be lost forever, this H and OH, and it is going to form a double bond. This double bond, as I have already told you, Markovnikov's rule with HBr or HI, this is two more favorable things, HBr or HI. So you can put the Br in with the carbon containing the less number of hydrogen. So here Br goes, because Br is negative, hydrogen is positive, Br goes to that part of the carbon that contains a lesser number of hydrogen, and this H comes with the CH2 from CH3 with aqueous KOH. Br will be replaced with OH, and you can see this is a carbon, this is the alpha carbon containing CH3, so 3 CH3, so this is a 3 degree alcohol, but here this carbon contains only one alkyl group, so it is 1 degree alcohol. Similarly, when we want to go for the second degree alcohol to 3rd degree alcohol, so this is the process how I will show you. This is 2 degree alcohol because this carbon contains 2 alkyl group. So this is the alpha carbon containing 2 alkyl groups, so 2 degree alcohol. when you are treating with K2CH27 in the presence of acid medium, in the presence of concentrated sulfuric acid, what happens? It is going to form ketone. This is called acetone. So CH3C, CH3 double bond O. And when you are using, this is Grignard reagent. This you have to use it for Grignard to increase the number of the alkyl groups. What you will be seeing here, the alkyl group present here will be joining with the with this carbon as CH3, and the other hand of the carbon with the oxygen joins with OMGBr, and on acid hydrolysis this MGBr will be released. So Mg has two of its hands open, one with Br and other with OH, and what you have is 3-degree alcohol. So student, this is very important that you convert from from methanol to ethanol, from ethanol to methanol, from 1 degree to 2 degree, from 1 degree to 3 degree, and 2-degree alcohol to 3-degree alcohol. So this is all about the interconversion. In our next episode, that is the 4th episode on the alcohol, phenols and ether, we will be learning more on the test. Be sure of your presence there so that you will be learning in vividly about how you are going to discriminate or how you are going to distinguish between the primary alcohol, secondary alcohol and tertiary alcohol. I will tell you students, you better read your book. There is oxidation process, there is Lucas test, and there is many a test with the nitrous acid also. You can get some tests. So go with that. In our next episode we are going to have all those things. Till then, goodbye.